This video is for section 7.5. Our objective in this section is to rationalize denominators containing one term. This is something that's going to be required later on when you're entering answers into MyMathLab. So this is a form of simplifying, and what it does is it rewrites a fraction so that there are no roots in the denominator. Roots are okay in the numerator, but not in the denominator. And it's one of those kind of old school things in math that was a lot more important in the days before calculators. Now that we have calculators, it's not really serving any type of purpose. But like I said, MyMathLab is going to require that you do this when you enter your answers for some problems that we're going to see later. So that's why we're covering this now. So when you see in a problem that they want it to be completely simplified, this is one of those things that they're going to require. So this is needed for it to be completely simplified. If you enter an answer into MyMathLab, that's the correct answer, but you don't rationalize the denominator, then MyMathLab is going to mark it wrong. So to rationalize the denominator, what you need to do is you need to multiply the top and bottom of the fraction by whatever root is in the denominator. And we'll see in an example how this works to get rid of the root that's in the denominator. So we're going to look first at an example that's in the text on page 544. It's 1 over square root of 3. We have square root of 3 in the denominator, and that's what we want to get rid of. So the way that we do that is we multiply the top and bottom by square root of 3, whatever square root is in the denominator. And the reason that this is allowed is because you're essentially multiplying by 1. When you multiply a fraction by the same thing in the top and bottom, that's multiplying by 1. Multiplying by 1 doesn't change the value of anything. So that's why it's allowed. 1 times the square root of 3 is the square root of 3. And square root of 3 times square root of 3, I'm going to use the product rule that we saw in the last section, section 7.3. 3 times 3 is 9, so this is the square root of 9. Now, the square root of 9, I can simplify that. That's a perfect square. That's 3. So this is my answer here. Now, I know it doesn't look like it's more simplified than what I originally started with, and a lot of times it may even look more complicated, but I no longer have a square root in the denominator, and that was my goal. So square root of 3 over 3. Next, we're going to look at example 3, and we're just going to look at part A. Rationalize the denominator, and it's the square root of 5 over the square root of 6. So I'm going to multiply the top and bottom by whatever square root is in the denominator. So in this case, it's going to be multiply by square root of 6. Now, in the top, what that's going to give me is I'm going to multiply 5 times 6, which is 30, and put that under the square root, so square root of 30. In the denominator, I'm going to have square root of 6 times 6, which is square root of 36. Square root of 36 is a perfect square. It's 6. So I can just write 6 without the square root symbol, and I no longer have a root in the denominator. So what should always happen here is you should always, when you multiply by the square root of whatever is in the denominator already, then that should give you a perfect square under the square root bar, and that makes the square root sign go away from the denominator. So next you should try checkpoint problem number 3, part A. Do this in your notes, check your answer, and then move on to the homework.